So coming here, okay. Today for the next 55 minutes I will have a presentation about the platform xPatterns Connect, and I just want to make a short assessment. How many of you are business analysts? Please raise your hand. This is cool. How many of you are developers? So I have to use those slides about development, which is fine. So I will get a little bit more in details about the architecture of the platform. You are open to ask questions. There will be a second presentation in the same time about how the platform works. It will be a showcase that will be demo by Lucian. How many of you heard about Mesos? So 3, 4, 5, 5.5, 5, 6. Tachyon. Spark. Wow. So that will be interesting today. So I'm quite happy. So what about me? My name is Radu Moldovan, and I'm coming from Timișoara, Tachyon. I have a team coming with me from Timișoara. You can ask them if you have questions. I've been working for the last 20 years in programming. I started earlier, and the last 3 years working big data. How many of you have been working in big data field? More than 3 years? More than 5 years? Oh, no, it's not me. It's not me. No. So it's only 3 years. And I'm a senior team lead is pretty much the same in Tachyon, and I want to present you what I'm doing right now. We are building with a team from Timișoara, but also Seattle, the 5th generation of xPatterns platform in the last 3 years. Please. So, technology. What is xPatterns Connect? It's a platform that you can consider it as a big data, big player. It's a software platform that helps people, and when I see people, I'm seeing developers, architects, data analysts, but also end users, because this platform is residing on a single machine and can be connected to a cluster, and helps people working very fast, starting proof of concepts without having that nightmares of installing things, preparing things, and it helps a lot. And I think it's one step beyond ETL and cluster configuration. The platform is divided in 3 categories, and each one addresses different issues, different problems, comes with different solutions. So in terms of infrastructure, I will discuss a little bit later, but everything about ingesting the data from external system or on premises on VPC in Amazon, prepare the data, clean up the data, normalize the data, and everything, it's part of infrastructure. So this is very interesting for developers, right? Because all of us try to normalize structured and unstructured data. We want to normalize the data to bring it to a shape that will be easier and usable for data scientists. So we provide also comprehensive toolbox for data scientists. Why? Because they have out-of-the-box Hive tables in different formats, Parquet in particular, that can be acquired, right? But also we have Spark, which we adopted 1.5 to 2 years ago, quite from the beginning. So once that we have the data and we have information about that, we can push the information into databases, NoSQL databases, and provide user interface applications. This is about the platform. So any of you can find the platform on the Amazon market, and you have 30 days trial. So it's up to you to pick up the running instance, install that out, and you have out of the blue a lot of tools that will be shown in a few minutes. Just to synthesize a little bit better about discussion, again, we have import data, we transform data, we prepare and explore the data. This is very interesting for data scientists. And in the end, we visualize the data. And I think this is the game. It's a major game for everyone. So let's discuss about the architecture. So I insist a little bit more here. What we have here, we have an image that could be considered divided in two. Let's suppose we have a cluster in the East Coast and the West Coast of the States, in this case, and in the East Coast, we want to prepare everything, but we have also plan B for the worst case scenario, right? So I think most of us have the same question received from the clients. What about fallback strategies and things like that? So the platform behind the scene, because will be also user interface presentation, is having something like a main clustering information where HDFS resides, but also we use Tachyon in top of HDFS files. What is Tachyon? Tachyon is the new kid on the block. Basically, it pick up the files from the file system and brings a new file system in memory. And this is quite interesting because, as you know, Spark is doing all the operations in memory, right? So we'll be fine to have a file system in memory and to create tables on top of those files in memory and process those data information in the memory. So I think this is the best combinations, which we have it right here. So we have Spark, we can provide Spark SQL queries, and we have the resource manager. So I think most of you learn about Hadoop, how it started initially with a job tracker and the task tracker. Later comes MapReduce 2 with Yarn and things like that. So we use Mesos. Why Mesos? Because it's running out there with managing more than 12,000 instances. And is doing just a great job. And what we have also, so this is the Tachyon, this is Mesos, this is Spark and HDFS that resides. What we have in extra for our cluster is the Zookeeper, which is usually, as most know, keeping the synchronization and configuration for the cluster, and not only, also for our application. And xPatterns Connect is the platform that brings the data from out of the cluster. Can be suppose we have a cluster on premise or a VPN, Amazon VPN. So we need to fetch the data. We have out of the box implementation to bring the data in the own cluster using sources like SFTP or S3, Amazon S3 and things like that. But also we have some proof of concepts for streaming integration to pick up a lot of small files. I don't know, 100,000 files that somehow reach Kafka, and then they are consolidated because the main node is limited from this point of view. So it's better to keep on HDFS larger files with chunk of data with delimiters. So this is what we have so far: ingestion and the repository, internal repository. Regarding the HDFS, we adopted an LDAP configuration for security, so each user for the platform has its own black box and can access only the data provided for him. What we've done so far, we put it all together in an ecosystem, and we provided processes that encodes and encrypts the data in the cluster and push it in the S3, Amazon S3, as a backup storage. And what we've done so far, we synchronize with the other hosts, pick up pretty much the same configuration that you have here, and in the worst case scenario, a balancer can switch from one host to another. So for end user, it's something that is trustworthy. It happens 2 years ago on Strata in States when Amazon had a failure, a big failure, and our company was the only one in 3 minutes with the product up and running, because we just switch in the balancer from one host to the other. So again, this is what we use for encryption and backup. So we have replication of the data in the clusters, but also on S3 as backup. In this picture, also we have two very important projects that has been created and outsourced by Tachyon. It's about Shark, because we have Spark, we have also Shark, which I'll give you a little bit more about this, but we have also JAWS. So JAWS is another new kid on the block. I will get in detail at the proper moment. And what we have also, we have this Spark Job REST, which is another open source project that provides REST APIs for Spark to create context, to run different jobs on the same context, kind of a sharing context between jobs. And this is done with direct impact in Mesos. Also, we use RabbitMQ, and this is a clustered version, but also workflow. Everything it's happened in the work nodes. It's pushed in RabbitMQ, and this information is later persisted in Cassandra. So most of the profiling of the platform, it's saved, and we provide history. What else we have in this platform? There are out of the blue tools for transforming the data using a workflow, and the end results for the workflow can be exported in the NoSQL database like Cassandra, or distributed search index as Solar Cloud. On top of Cassandra and Solar, because they are used because they are very performant, we can provide later APIs for third-party companies to create user interface and to decrease the time to market for their products. So if you have questions about the architecture of what did that Shark do? So in fact, that Shark is JAWS. It's called JAWS. It is patient, please. So I will get a little bit more in details about that. What I would like to have right now is to have a presentation about the platform in real time, but I try with two different internet providers, and things don't look quite good. I'll try to provide you the platform, which is like this. So what is important to understand is we have different modules and different users and a model for administration that put together the modules, configuration for modules and things like that. So I won't insist in too much about administration, but I will go with the capabilities about the platform. So it's very easy to define an S3 or FTP source. So it's easy to provide the bucket, the source folder, right, access key, secret key for S3. And this is the nice part of the platform. It's just up to you to decide how the fetch is done in a parallel way. And the beauty behind the scene is the fact that you can consolidate the files. So suppose you have, I don't know, 1 billion files out there in S3. It's quite impossible to fetch that information to add it in HDFS. So just clicking this option, the files get consolidated, and you have also the option to sort the information in Tachyon, which is a pretty smart thing. And I think my colleagues in the company just did a great job. It's something out of the blue. You just have to provide two elements, and you have the data in your cluster. It's just like that. And once you have the data defined and prepared, you can, for example, this is an information provided already. You can use the source later in the workflow. Workflow is, and let me give you, okay. Let me see if I think it's better now. What is workflow? Workflow is another component in the platform which put together different technologies and gives the development department in a company to use Scala, to use Java, to put together Spark jobs, but also Java, add some actions like shell and SSH, put together Spark SQL, but also Hive. I mean, it's something all in one. It's only up to you to create a workflow that somehow cover your needs. And this is pretty interesting because it's much more than a workflow. Just imagine everything that happens in the cluster, it's tracked and it's put it all together in one place. You don't have to connect to, I don't know, a working machine, to switch on the log directory, trying to tail something. You have it all one together. So it's very important to understand that, and I will start also this job, just to give you a short idea about the platform. So as you can see, we have the designer. We can add, remove, fork. We have fork and joins to work in parallel, to start tasks in the parallel. But basically, those are stages. And what is important to see is everything is provided. So it's very easy to track also for each job what are the elements from a configurable point of view, but also the progress. And the nice part also, there are the metrics right here. I won't insist on that, but it's easy for us to submit a driver program. I think I am using terminology from Spark. So in case you don't understand what is a driver, it's the main part of implementation that resides in the master, and you have the chance to process the data in a parallel mode, pushing part of the operations over the nodes, working nodes. So as you can see, there are stages that pick up the information for the import, working in parallel, using the entire resource from the cluster. Stages can be configured to run, and I will show you because this is another beautiful part of the implementation. For example, if you want to run, I don't know, a code, in this case it's a Spark job written in Java. It's easy to provide parameters that are can be read from the driver code, and we can act accordingly. We provide as an open source all the interfaces that platform supports for Java and for Scala. You can extend and implement those interfaces, provide your code right there, build a jar, add it, and run the job. The nice part is that everything you see here as a user interface is provided through the REST API. So starting with ingestion, continuing with workflow, but also Warehouse Explorer, based on building on top of JAWS, provides REST API. So it's very easy if you don't want to use this user interface and this platform to use the services behind. So regarding the Mesos, right here I have a very important section, because most of the cases we have to find a balance between jobs that need a very specific amount of resources in terms of memory, CPUs, but also we have to try to prepare and to run tasks from, I don't know, for statistics, which are not quite important to be run in real time, but in near real time. So what we have here, we provide to the resource manager, in our case Mesos, what we want, unlimited and limited. And we can configure how many resources we want to use for the jobs. So as you can see, we have the jar file within the implementation. So also for Hive is very interesting to upload the resource. So this is I don't know, something that we want to perform in a very easy way. Just upload the HQL format, provide parameters out from the configuration stage. So it's very easy to apply different function over the data. So in the end, we have a status about each stage with the logs. Everything, it's in the same place. Everything is unified. And we use Uzi as a technology for the workflow. So we subscribe to all his updates, and we put it all together right here. So it's not necessary to adapt and to learn so many ports, working ports, user interfaces for all the technologies, because you have it all in one place. As you can see, we have also starters here, like user interfaces, meaning people pushing the button, but also we have a scheduler. So it's very easy to configure maybe a daily ingestion, right? So it happened to have clients in medical vertical, and every day hundreds of millions of data come into the picture. We have to create a delta updates to see how to merge those information. So that information, and it's very easy once you have everything in place, just to use the schedule and to leave the system to do the job for you. Next section, yes, it's a section that, as I said before, and so I ask you your question. It's an explorer built on top of JAWS. It's a REST API that allows you to perform asynchronous queries over Hive Metastore. It has history and logs persisted in Cassandra, so it's easy for you to see how the queries perform, and it's a very useful tool also for data scientists, not only for developers. Again, you have it all in one place. Everything is persisted. You are allowed to search through the all databases and tables. Regarding the experimentation and administration, because I don't have time, I will switch again in the presentation mode. Pretty much the same that I've told you about, it's right here. We have also metrics, so it's good to understand, especially those that have experience in Spark. It's quite hard to see what is the progress for a job. And it was a question also before. With this platform, you can interrupt, suspend, resume, or kill a job, just like that. Because the job resides in a context created with Spark Job Server REST API provided, so it's easy to release the resources in the cluster. So this is the part with experimentation, where the data scientist has a very smart tool that put together using Python language, but also Python libraries to perform machine learning. I have few examples here, like decision trees, and also there are third-party libraries written in Python to make drawings and statistics. Regarding the monitoring part, we use Nagios, but also Ganglia. I won't get too much in details, but as you can see, we all the time monitor the performance of the clusters. We can, regarding different technologies, you can see Cassandra, the front ends, all Mesos and Tachyon workers. Everything is out there. In worst case, something is wrong. Based on service alert process, we receive everything in real time. Those are, for example, few items that we check in case of Mesos, for example, and for Cassandra. Ganglia is very useful for us to get the performance in terms of memory, CPUs, network. Using Swagger, an open source technology, we provide in real-time REST API for all our components. So once we have a new distribution for our APIs, automatically all the contracts with the third-party users are out there. Documentation, samples, where it very well document that part with performing the stages and jobs in the workflow. And just as a conclusion, I would like to highlight a few things about the platform. So just think about data integration. It is smart, it is easy, it's 10 seconds if you have the credentials. Then during the processing of the data and export to Solr, we can create semantic search, and it's very powerful engine for this point of view. Using Spark and jobs written for Spark, we can provide recommendations which runs in a real time, but also we have predictive analytics. Is that part of experimentation that I told you about? It's strictly and strongly related to the data scientists, so we provide a tool for everyone in a company. And visualization, yes, is the last part, and I will spend only 2 minutes from now and to finish. For example, we have ingested the Enron emails. It's a public repository with all emails that and messages written in a company. So I will go here and I don't know, I'll trade. I will search for a term. Oh, okay, on the other side. Okay. And for example, it's easy to see in the system who wrote an email that, I don't know, use the word trade. And using sentiment analysis, we can perform different statements that says that information it wasn't supposed to be in an email, things like that. The nice part is that it's easy to see how the information is linked to other persons. So, and load information about the emails. It's everything out there. Also, I will try for a medical sample. We have ingested a PubMed. Lucian will provide you the flow, how the platform help us to provide you this application. Unfortunately, as I expected, the internet. Oh, great! So what we have here, I don't know. It's everything about an aspirin, how things are related to each other. So a doctor can navigate and very easy and to narrow all the question in time just to get the right information. So it's easy to search more terms strictly related to this one. So as you can see, there are a lot of things that can be done here. We create a domain expert indexes for those. It's possible to search for so everything is out there. It's big data in real time. Thank you. Lucian will present this in the second part. How questions, please. 1 second, because I have to repeat the question otherwise.
Okay. Hello. So yes. If I understood correctly, you're not installing xPattern over a cluster. It actually comes with the cluster. So my question is, if it also provides administration features like Cloudera Manager would provide, or maybe you need to tweak some configurations, or
okay, that's fine. So thank you for that question. I was having the intention to say something about Cloudera Manager, or I don't know, Hortonworks, right? So we have clients that manage the cluster by their own, right? So it's fine for us. So sorry for that. Enjoy the moment otherwise. So yes, we have clients with different recipes for maintenance and for cluster management, but we can stay near to those clusters, just connect the most important ports for HDFS, right? Name nodes for Hive that comes with Cloudera, for Uzi that comes with Cloudera, Solver that comes with Cloudera. But there are some things that don't come with Cloudera, like Cassandra and other third-party technologies. So it's fine for us. You can continue working with your management distribution for the cluster, and think about this platform. That's why it's Connect. It's just another instance that you configure to communicate with all the ports provided by Cloudera. Yes, we can use it without Cloudera. So we have out of the blue Hadoop distribution open source one, not the one built with Cloudera. We provide Uzi out of the from the community. So we have all those things installed in a cluster without Cloudera. Yeah. Other questions? Right. Yes, we have ontologies. So that's why it's a domain expert, because we analyze the data and export the data in Cassandra. So strongly depending on the needs, there are searches, search requests made to Solr, but also to Cassandra, just to have everything in place. Other questions, please?
Hi. Did you ever had to deal with aggregation on Hive, like huge aggregation mechanisms? And what was the performance impact and so on?
So the question was strictly related to Hive. Yes, we work with Hive, I don't know, as I remember, version 9. But in time, the next version of Hive solved the problems. Hive 10, 11 brought new capabilities for grouping things. As far as I remember, because it was 2 years ago, but maybe Radu, Emma, you used bags, right, in Hive to optimize. So that is an answer. The second one will be to use a hash key to partition your data, so it will be easier for you. But the right answer is Spark. Why Spark? Because it helps you to broadcast the collection. Suppose we have two collections, A and B, right? And you want to join them. If B it's significantly smaller than A, you can broadcast that in all the nodes. So the join can be done using SQL or HQL in Spark, and will be much, a performance is consistently great than using direct only Hive. So change the technology. Yes, exactly. Yes. Exactly. Yes. So in Cassandra, you push the data that fits the showcase for the user interface. Everything else stays on Tachyon and Spark. So think about processing data in near real time and export that data in NoSQL database or search engines like, I don't know, Elasticsearch, Solr, Cloud, things like that. So strongly depending on the needs, you push the data, prepare the user interface, and with this platform you are also able to create dynamically REST APIs on top of the data to be consumed by the user interface. Yes, please.
From Cloudera, we have also Hue. That looks pretty much the same. Do you guys provide an alternative, or it's something more than that?
Let's suppose that our target is not Hue, and we haven't focused so much in this area. But it is, I know I work with Cloudera, I know what is Hue, stands together with Hive and do all the things together. Maybe if you have something more precisely in your mind and give me the right scenario, maybe I can help you.
So as far as I understood, you provide something for data-driven researchers and so on. Basically, you have the same on Hue, and you have the same implementation in your xPattern. So my question was, do you guys provide something more than that, or it's pretty much the same? It's an alternative for two tools.
If you, I don't know, strongly depending on your version of Cloudera, most of the Hive queries are translated in MapReduce jobs, right? Which are performant on top of Hadoop, right? we discuss here about something that has map and reduce and many other functions that Spark provides. So it's kind of an alternative. It's not something that we want to replace or to offer. As a Spark SQL. Yeah. So again, switch the technology. So Lucian, you still have 40 minutes, 50 minutes to present your...
Felix Enescu from Consult Blue, Alex Shishu from Atigeo. A panel scaling data processing pipeline in big data.
Mulțumesc. Okay. No.
So we have 50 minutes and we split. Okay. So we still have 40 minutes. Don't worry.
Okay. So my name is Lucian. I'm a software engineer for about 5 years, and I've been with Tachyon in the last 3. My work here implied some Hadoop streaming in Python that was in the old stack. I did some monitoring work for both the at the OS level and both for our services using Nagios and Ganglia. And in the last period, I've been working on a publisher module using Spark and Soror Cloud. So what you're seeing here is a demo job for ingesting some PubMed files, processing them on top of a Spark cluster, and then throwing them in a Soror Cloud cluster. So the first stage, I have previously placed some files in S3, and this stage fetches them and throws them in HDFS. PubMed actually here is a misnomer because PubMed is a search engine which was freed, open to the public, I don't know, about almost 20 years ago. But the database behind it, it's Medline, the Medline dataset, which contains articles from journals like in the fields of medicine and pharmacy and the full text articles, and also the citations, which are only the abstracts of the articles and the link to the full article. That's the main 2 categories. They're usually in custom format, XML or SGML, I don't know. So they need a little bit of processing, a little bit of normalization. What Radu showed you, I think in this tab, it was on the old stack using MapReduce jobs. So in my demo, we're using a Spark. Let me find it again, okay. We're using a Spark cluster, which basically takes all these files from the HDFS, gathers some information about their location, parses them, looks for specific information like the title, the description, the ID, the list of authors for each one in a distributed fashion, and then writes them all in this case in Tachyon, but can also write it in HDFS. Okay, I'm a little bit clumsy. The scroll is backwards, so bear with me. Okay. I can't find it. Anyway, So yeah, here you can just update the endpoint to HDFS and the IP endpoint port of the machine you would like to place them. They will be placed in a Parquet format. So I've mentioned Tachyon, which Radu already explained what it is, a memory-centric distributed system that stores or caches in memory the most frequent files. And Parquet is a columnar data format which has two main benefits. It stores all the data similar in one single row, so you can have better compression. And if you have a field that you don't want to retrieve in your query, you can skip it all together, so you have some performance improvement here. So the last stage of this job, what it does, it takes these sources from Tachyon and creates a new collection in Solr. You can configure it here, but again, I'm not able to show you this. You can configure the number of shards, the number of replicas, and yeah, let me give it a try. Okay, thanks. The number of shards, the number of replicas. If you want to do a batch commit, you may choose the number of the items you want in a batch to be exported. This is, I have to tell you a little secret. This is the first version of what we tried. This evolved later into a product of its own. It's called the publisher module, and has spawned some siblings. It's called publish to search, and has spawned some siblings like publish to NoSQL, which is obviously backed by Cassandra, and publish to Elasticsearch. So I could obviously run this, but I've already done it a few times. I want just to show you the end result. We have here two collections, the PubMed article samples, which was generated from files in HDFS, and the PubMed article samples Tachyon, which was generated using data in Tachyon. Damn. There we go. A mouse to the safe. Okay. I'm gonna show you how the data we processed looks like. It's not much. I think it's 13 articles. But the main point is storing the data in Parquet allows us to store the data and the schema, aka the metadata, in the same place. We chose this format because we didn't want to use costly reflection to infer the schema of the data, or as the user, each time he wants to export the data, yeah, please give me your schema. So yeah, I think that's about it. Thank you. Thank you. Yeah, if you have any questions, please.